All right, I think we're live, sort of. I'm having internet troubles, and it might actually affect what we're going to do today because originally we were going to put Octoprint on our printer, well, on a Raspberry Pi connected to our printer, which we can still do most of that, but I don't know if I'll actually be able to connect to it because I'm using my phone for internet service, and I don't know if I'll be able to run it through that way or not, and still make it show on the screen what I'm doing. We'll see how far we can get. We'll give it a shot. I do have some other things that we can look at in the meantime if we can't do this because of the internet being a problem, or lack of internet being a problem. You actually don't need internet. You just need a local network. You do have to go download some files in order for Octoprint to work. And the problem is I have a local network, but if I connect to that, then I can't stream to you. So we might have some issues trying to get this to work. We'll see what happens. I don't know. Right now we're streaming on how to get started with Octoprint. We may not today be able to actually show Octoprint, though. We'll see. So what is Octoprint? It is a software package. So there's a whole suite of things that can plug into Octoprint, or you might hear Octopi. Those are the same thing, sort of. They're based on the same thing. Octoprint is sort of a, let's go to the front page of it, pre-packaged version that's ready to go for the most part. You have to do a couple of setup things to get it started on your printer, but they've actually, I just noticed that they've changed the setup routine a little bit to make it even simpler to do. So we will see. We'll see how far we can get. So what it does is, first of all, it runs on a Raspberry Pi. So I've got this guy over here. Now, this is a cable to connect a camera, which is not connected to it right now. You can have just a webcam, like a USB. There's USB ports on a Raspberry Pi. This inside this case is a Raspberry Pi 3B Plus. It's not the very newest Raspberry Pi. They actually have Raspberry Pi 4s now. This one's a little bit older, but therefore it's a little bit cheaper. And it's plenty for what you want to do with Octoprint. In fact, let's see if we can figure out how much one might cost. I usually buy them from Amazon. Let's see. There's a Model B. That's actually too expensive. That's not the right thing. There's a B Plus for $60. Or maybe they're actually harder to find now, because there's a whole kit for a B Plus with the power supply. And usually these come with a case. I don't see the case on this one. It looks like it has maybe an on-off switch. It might be that the 4s are cheaper now. Maybe the 3s aren't as available. I wonder if that's true. No, that's definitely, there must be something going on here. Maybe some of the global shortages on electronics are affecting these, because these are a little bit more expensive than they've been in the past. I know I didn't pay quite this for these. So maybe right now, unless you already have a Raspberry Pi, might not be the best time to start with Octoprint, but maybe you already have one. You already have an old 3 or whatever. It doesn't have to be the B Plus. I think the B Plus adds a little bit more memory to the Pi. I would not go down all the way to like the Pi Zeros. There probably could run on a Zero with the wireless. So I guess that's the 0W. That would probably run, but what you would probably end up having is some lag between communication of your Pi and the printer, and that's probably going to end up with blobs on the surface of your printer, because any amount of lag, delay in the communication of whatever needs to be happening to the printer, is going to cause the print head, the nozzle, to, even for a millisecond, stop, or well, maybe a few milliseconds, stop and pause while it's waiting on that next command to come in, and that pause is going to cause a blob on the surface. And the Pi Zeros probably are just not going to be able to keep up with most things, particularly if it's a very curvy model. You know, it's got a lot of organic shapes and therefore a lot of little individual line segments. probably is going to not perform well. You could try it, and you can certainly install Octoprint on there. That's not the problem. It's just the communication, processing, sending the information to the printer. Your printer, you don't actually change anything on your printer. You just plug in fact, let's look over here what you do. So you know how your printer down in here, let's see if we can find it. Yeah, right there, has a USB port. You just plug that USB port into your Raspberry Pi, and that's the amount of connection you have to do. Now, I'm going to mount this later. In fact, I've got a couple of things on order. I've got this. So the Raspberry Pi runs off of, I think it's probably a 5-volt source, or maybe it can take 12. The problem is the Ender power supply is 24 volts, and that's too much for it. So these little guys are buck converters or step down converters or whatever you want to call them. I think they're calling both on this listing. And so these can take anywhere from 4 to 38 volts in and output anywhere from 1.25 to 36 volts. So I'll just set them to output I think it's 5 volts. I'll have to check and see it. No, it's not 24 volts that runs a Raspberry Pi. I know you can run them off of a USB, so that should be 5 volts, a USB from a computer. So got this guy. Actually, I got 4 of these guys. That were cheaper than buying an individual one in a fancy case. We'll just print a case for it. So I got that and one of these little XT60 connectors. So this is the kind of connector that's on the back of your Ender 3 from the power supply to the motherboard. That's the type of connector that is plugging it together. And so we're going to intercept that. And these have this little pigtail that comes off of them. I guess I got 2 of these for $9. I have an extra. This is not a bad thing to have because there are other things that you might want to put on your printer that don't run on 24 volts. Maybe you want some quieter fans. Most of the quiet fans, not everyone, but most of the quiet fans run on 12 volts. And so you could split off some 24 volts, run it through one of these guys, and drop down to 12 volts. And so there might be reasons why you want to run something like this. So this little guy will let us plug into our power supply. We don't have to splice into it with soldering and stuff like that. We can just plug it in, and we get a pigtail that comes off that is 24 volts still. We can run the 24 volts one of these and drop it down to whatever we want within the range of 1.25 to 36 volts, which is fine. So for what I'm going to do right now, I've just got a charging cable that we will plug in here, and that will power our Raspberry Pi. And so it's just plugged into a wall. It's a wall converter that probably puts out 5 volts already. It doesn't put out 24 volts anyway. So we can get that far pretty easily. Then we go to Octoprint itself. So this is octoprint.org. And there's a lot of links up here across the top. You go to the download, and this is where they've changed things up, and I don't know when, since the last time I installed Octoprint, so since last winter, this past winter. And they do say, here are the recommended versions. If you do any of the Raspberry Pis below the 3B, so there's a 2, in fact, they're saying the 0W is explicitly not recommended. So I wouldn't do that. You can get it to run, but it will perform badly. Expect print artifacts, so that's the blobs on the surface, and long loading times with any of the lower level Raspberry Pis. So if you still have a 2 out there, or one of these zeros, or something like that, it's probably not going to work very well. So we're right in the middle. We're at the 3B plus is what we've got. You can, like I said, you can attach just a regular webcam, which I do have one over here that if we can get far enough to actually get the thing to run, I'll see if I can. I don't know if I can get it unplugged very easily, but you can plug in a regular webcam, or you can plug in the Pi Cam. There's a couple of versions of the Pi Cam. They're usually in the, let's see what price they're in. Let's see. Well, there's a fancy one with a wide angle lens on it for $50. Here's the one that I have that doesn't appear to be offered right now. $14 with the cable. If you do this, you probably want the longer cable. Oh, not showing it on screen. There we go. So these are the ones I was scrolling through. This one has a wide angle lens. Never used that one. It would work, but I've never used it. This one has some software, well, hardware built in for object tracking. Probably don't need that either. This is kind of where you're at. One of these two. So there is a older version of the PiCam and a newer version. Actually, this one says it's the ArduCam, so like working with the Arduino, but it's got the same adapter that would plug it into a Raspberry Pi. This little guy is, it says it's 5 megapixel, but I think there's a newer one that I'm not seeing right now. There's several of these to choose from. So they're in the $10 range or whatever. They do come on a little board that's just kind of out in the open, so you probably have to print a housing and some kind of mount for them. The one thing I would say is that you do need one that has the longer, like this one has a 3-foot cable. Otherwise, the cable that comes with them will work. It's just going to mean that the camera has a very limited range of where it can be in relation to the Raspberry Pi itself. So the ones that come with the longer cable, like this little package right here, would be fine if you didn't want to assign a webcam to monitoring the thing. You don't need it at all, but it is kind of nice. Particularly, the goal of this is you're going to have your printer remotely accessible. And so that means it's off in another room somewhere. I've got the Prusa in another room, and it's set up with Raspberry Pi, Octoprint, and a camera. One of these actually is probably this one that is on there. And so I could, if I were connected to my local network, which I'm not right now, I could log in and send a print to it. I could monitor what's going on it through the camera. It'll give me feedback about, the temperature of the bed and the nozzle and all that sort of stuff. And I would never have to go to look at it. Obviously, I probably would just to, check on things, but I wouldn't have to. So these are kind of set up where you got the printer is off in a garage, or it's somewhere that's you don't want to run down to every time. It was in the basement, and you just want to have access to it. I like it even when the printer's sitting right beside me right here. I like it because I don't have to deal with the SD card. So I can just send files. It's sitting right here. I slice them on my computer and send them right there. I don't have to deal with the SD card. It actually is a much more convenient solution. Now, is it $100 more convenient solution? I don't know. So I would try to find the Raspberry Pi at a little bit more affordable price than what it looks like they're at right now. They kind of look expensive right now from what I remember them normally costing. Or maybe I'm just forgetting what they normally cost. All right, so you can attach a camera, but you don't have to. All of that to say that. So here's the installation procedure. Now they do have kits. I didn't check on this. Let's see. They do have kits already set up. You just put your Wi-Fi password into it, and it should be ready to go. Let's see. Here's one that's got the webcam already in it. Let's see how much they are selling these things for. That did say UK on it though. 160 pounds. That's kind of expensive-ish. Although it does have a little webcam. I don't know if that one's particularly, it might be a $10 webcam. But anyway, you could get it already set up. Here's a US kit. Let's see what so that's actually not that far off of what you pay to just buy the Raspberry Pi if you're getting the Raspberry Pi 4. Now this probably doesn't have a 4. Oh, it does. This has a Pi 4B in the $100 range. Right now on Amazon, you can't get the 4B for much less than that. You've got the heat sinks for the Pi. You have some little case. You actually even have a fan to cool the Pi. They're passively cooled normally with just the heat sinks. So this case has a fan on. This actually isn't a bad deal compared to other prices right now. Assuming it's in stock and you can actually get it in a reasonable amount of time. That's not a horrible price. So that would be an option. Just click here, buy the thing if you don't have anything to start with already, and you're done. You just wait for it to show up. if you do have some Raspberry Pi already sitting around, and you have the little SD card, remember they have a SD card slot back here, back there, that you put the operating system on. Then here's where they've changed things up from what I remember in the past doing, and the past being last winter. They have a Raspberry Pi imager now. Now, not Octoprint, but the whole Raspberry Pi. So this can actually image all sorts of operating systems on here. I downloaded it, and let's see if it's, yeah, it's running right here. So when you download it, you get this screen when you run it. And there are, let's see. So you can just install the normal Linux type based operating system. There's other things, I don't know what's in here. A light version, a 32-bit version, general purpose operating systems. There's some other Linux type things. There's a RISC setup. They've got RetroPie, so maybe you want to run some retro video games on here. You could just click the button. It doesn't install any of the ROMs, but it installs the emulators. Or I guess it does. I haven't installed that. A lot of different things. If you go to other language specific operating systems, then no, not other language, other specific purpose. Not we want our language we can actually understand. So other specific purpose operating systems. There's Octopi in there. So Octoprint is based on Octopi, and so we would click that. And then there's just two versions for where you want to download. These are the same thing. One's a mirror in case the other one's slow. So it looks like this one was out late January of this year. Then you pick where you want to put the thing. So you need a SD card with, I think this is an 8 gigabyte SD card. That's way more than I'll need for this, but you pick the SD card and then you click write. It will format, or it should format over everything on the SD card already. Oh, one other thing, you can at this point go in Control-Shift-X. I don't know why this is the thing, but there are options for this session, meaning this write session that you're about to write to the SD card. There are things that you can do. One of them is configure Wi-Fi. This is where I'm on my phone, so yeah, that's going to be a problem probably, but we'll do it. Well, I'll have to do it, reset these Wi-Fi settings. Normally you'd set in your Wi-Fi settings for where your internet normally connects, because that's probably the same thing that you're going to use. Although you don't have to have internet, you just need a local network. You had to have internet to download all this stuff. You do have to have internet to write this, because it's going to go download that Octopi that we clicked on with the one that had the mirror. So it is going to go download that. It's not already built into here. So you do have to be connected to the internet to do that part. So if we click write, I have no idea. All existing data will be erased. So it is going to format the SD card. So make sure that you don't have anything on the SD card that looks important to you. We do want to continue. So it's going to do its thing. It opened a window over here on the other side that I think was just it kind of recognizing the SD card as being initiated. I want to close that window and see if it, yeah. I closed the window and it started doing that. Now, a lot of times these SD cards, now that you have, or once we do have this operating system on there for Octoprint, it will, if you ever put it back in your PC, it's going to ask you to format it. It doesn't recognize it. You know, it's got an error or something like that. Don't do any of those things. Don't repair it. Don't format it or anything, or you'll have to do this all over again, because it doesn't work like a regular SD card necessarily anymore, because it does have an operating system on it, its own file structure and everything. So don't go and put it in a computer thinking that you're going to just tweak something. You can do that, but don't select any of the options to repair it or format it or anything like that, because then you have to redo this part. So we are writing. And this is the part where I don't feel like we're going to have a problem. The problem I feel like we're going to have is when I go to try to connect to it, because it's in a weird, I don't really know its IP address. Normally what you would do is you would have put in your information for your local network name and the password. Now this does create a problem if, say, you're at school and you have to log in with a username and a password. That's actually a lot harder to do because it's not asking you for a username. So you do have to go in and do quite a bit of setup to make it work. It is probably easier just to buy you a router, set your own local network so that you can control username and password than it is to get it to work with a enterprise type network where you have a username and a password and you're one of thousands of users on the network. That the problems with those are that every time you start the Octoprint server again, it's going to collect a new IP address, and you don't know what that IP address is. There are workarounds. What you can do is, if none of this makes sense, that's fine, because it doesn't. It's not a simple thing, but the only way I've ever figured out that you can make it work with an enterprise where you get a dynamic IP address over and over again every time you start up is to write a little script that sits on the Octoprint, the Raspberry Pi, and whenever it boots up, it sends out, it gets its IP address and then collects that and sends you a text or an email that says my IP address is now, and then spits out whatever the IP address is. Then you can take that and connect to the Octoprint server, because otherwise you don't know what it's going to be. If you don't have a static IP address, one that doesn't change every time you boot it up, then it's a pain. Plus, you have the issue of you have to log into an enterprise type account where you have to put in a username and password. So that takes a little bit more digging around into the host list in the on the Octoprint thing. So it's way easier if you're on a local network that you control. You just put in the network name and password to that network that you set, and you are pretty sure that you had set it up where it gets a static IP address. Even if you turn it off and turn it back on, it reports back to that same IP address. Otherwise, you're going to have constant headaches with always trying to figure out what the IP address is for the thing. And that's where we're probably going to get stuck, is because I don't know if I'll be able to tell what its IP address is so that I can connect to it. We'll see. It's still writing. I guess while it's doing its thing, let's look over here, because I do have some other stuff that once we get stuck, we can move over to the other things. One of the things is I did get in the 0.6 millimeter nozzles. Remember a while back we changed out the nozzle. Still got a print on the printer. Changed out the nozzle to we changed the whole hot end, didn't we? So we have an E3D V6 hot end on there, and I wanted to put a bigger nozzle on it so we can do some printing with larger scale models. So you can kind of see I've got a dinosaur, or half of a dinosaur skull on there right now. And I only had a 0.8, I think it was, millimeter nozzle that would fit. And that was just a little bit more than I wanted to deal with. So I ordered 0.6 hardened nozzle, put that in here, and we've been doing a little bit of printing. So this, I'm trying to get the settings correct, because now this print took 5 hours and 7 minutes, it said, where normally if you slice this thing in Cura, it's 11 plus hour print. Now I'm using thicker layer lines, so you can probably, I don't know if you can see them on the, yeah, you can see them. Surely it's not really focusing on them that well, but maybe we can make it focus. No, this color just is not a great color for working on this camera. But anyway, the problem comes in when you're trying to push out so much more filament than you were before. So you got to get the temperature correct, the speeds correct. So I've had to slow the print head movement speed down a lot. So I'm printing at like, I don't know, 30 millimeters per second where it was 60, so half speed. But my layers are so much thicker than they were. This is a 0.48 millimeter thick layer. Almost no infill. It has a tiny bit of infill just because I think it's 5%. So there's a tiny bit of infill, and I've got to get some of the settings tuned up. You can still see there are some instances right in there. You can probably see, it's going to have things like this because I also didn't support it. So it's just kind of printing in midair there. But you got to do some tuning, and I just didn't want to do that amount of tuning with the 0.8 millimeter nozzle. One of the things that's happening, though, is when it transitions from going the infill to the perimeters, is it's having a little bit of issue keeping up. So the infill, I have that printing a lot slower too, but it's still faster. I guess I could slow it down some more, but it's kind of almost getting a clog between infill and the perimeters. So it's skipping a little bit. So one thing we're going to do, I've adjusted temperatures and speeds and things like that, but now what we're going to do is I've got this guy. I was going to put this on anyway. What this will do is help us have a little bit less skipping on our feeder. So if we can get it open. There we go. What this is it replaces the top of your feeder with some new parts. They are metal parts. That's not that's good, but that's not the point of it. The point of it is these two parts. So here and here, they're geared together. So now I'm gripping, let's see if we can zoom in on that. Our right finished on our print, or on our deal. So these are geared together so that the filament is going to be trapped between these two, and they're both turning. So they're both driving the filament into the hot end. So I'll have a little bit better grip on the filament, and I'm driving it from both sides, whereas the feeder that comes standard on the ender has one drive wheel that's connected, well, it would be this one, connected to the stepper motor, and the other one's just a idler type pulley. It doesn't drive, or it doesn't even grip, it's just a pulley. So this will give us a little bit better grip on our filament as it's feeding in, and so hopefully have a little bit less likelihood of skipping. Now these things, this one does look like it's one of the better ones. So let's get the camera back in its normal spot because it's all over the place. And see if we can zoom in on this so I can show you the part that makes this one better. So what you want is this chamfer down here. See how it doesn't come to a flat end. It's chamfered on the bottom of that. If it's not chamfered, even if it is, you're going to eventually wear it out. But if it's not chamfered, it's going to eat this bottom. This is just aluminum. So it's going to eat that surface completely away. You're going to get, and it won't even take long. It'll, a couple of weeks of printing at best, and this bottom part is going to be eaten away to the point that this can move up and down. You've got little aluminum filings everywhere, and so it's just a big mess, and it probably has quit working at that point. So this chamfer on the bottom of here helps prevent that from happening. The best ones even have a little washer surface in between these two. This one doesn't seem to have that, but at least it's chamfered to where it's not going to eat the bottom of the support away. So once we get stuck on our Octoprint, then we'll put this guy on because we need it to help out with our system. So here's what we've got. Actually, let's look at this one. Octopi has been written to the USB device, so that was the SD card. You can now remove it from the reader. All right, let's do that. I don't know if I want to eject it or remove it. I'm going to just remove it and hope that doesn't break anything. All right, now we can still do this part. All we're going to do is put this guy in here. So let me see where it goes. Like that. You have to be very careful with these. A case is definitely valuable because this is just hanging out on the end, and it's easy to break that off, break the SD card, or break the socket off of there. So we've got it plugged in to the printer back here and to one of the USB cables. We're going to power it on. Should I do that yet? Let's see. Yeah, because it wants it. Well, I guess it doesn't necessarily have to be connected to the printer yet, because what will happen is the power from this will actually turn on the at least the motherboard of the printer. You won't be able to print or anything, but it will turn it on. So I'm going to leave that unplugged for now and just plug the power in to the Raspberry Pi. So I get a little red light somewhere that it's booting up, and I might be able to tell on my phone if it connects to it or not. We will see. So far it hasn't, but this is like a little computer now with its own operating system, so it's booting up. One of the things it wants to do is connect to that Wi-Fi, whatever we put in right here. Now, if I didn't get that set right, or there's any problem with it, then that's where we won't be able to get very far, because at that point what we need to do is talk to it. We need to log into the server over here on the printer, which so far I haven't seen anything else connect to my phone. So it may not want to connect to my phone, because it's normally not expecting to connect to that. So that may be all that we can do right now on Octoprint. We'll go through the rest of what you would do just looking through it, and maybe that'll give it some time. Although I don't think it actually is flashing like it wants to connect to something, and it's trying to. It just hadn't done it. So I will give it some while and see if it'll connect. If we can't get it connected today, which I'm kind of thinking we won't, then we'll come back and finish up the rest of Octoprint at another time. So this is where you're on your PC. So you're on your PC, you want to log into the Pi. So the Pi should be connected to your local network, which, it's not appearing to be on mine, but on my phone's network anyway. So it would show up, it would have an IP address. It's possible that you can do this, just type octopi.local into your address bar of your web browser. That's if your computer supports Bonjour. So that's probably not true, unless you're on a Mac. If you're on a Mac, then it's already built into there. If you're on a PC, then that's probably not true. There are some add-ins. I think, like if you've installed iTunes or something like that on your PC, then it would have Bonjour server running on it also. But unless you've done something like that is going to install the Bonjour service, then it's probably not already there. So probably what you have to do is you just type in the IP address from your router. So to do that, you would have to go in and figure out what the IP address is. Most of the time, you can log into your router with, what is it, 190.1.1.1. I think that might be it. Let's see. Log into router. Let's see. 192.168. All right, so says most routers. Now I don't know if this is going to be true for your router, so you might have to do a little bit of digging to figure out how to log into your router. But 192.168.1.1 is what most routers use as their address, their own address. And so you can log into it, and then if you've never done that before, you probably should, just to see, because it'll show you everything that's connected to that router. It'll show you, you know, your phone and your iPad, and it'll see if there's any other things that are connected to the router that you didn't know were connected to the router. And so it might be good to just, you know, do a little house cleaning to see what all's connected to the thing. One of the things should actually show up as, I think it'll show up as Octoprint in the list of things connected to your router. And so there's other things you can change the router password there. You can do add in filters and all sort of things. So there's a lot of other maintenance type things that you can do there at that address. So that would be one way to figure out what the IP address is, and that's probably what you're going to have to do if you're on a PC that doesn't have the Bonjour service running somewhere. Now, if you do have that, or if you go figure out how to install it, just install iTunes or something like that, and that will install it, then you can use octopi.local, and that will be it's not its IP address, but it's an address that will lead to it. It has a default username and password. So this part, you don't actually have to do this, except that this is how you can change the username and password of the Raspberry Pi itself. Now, I think you can also do that in this advanced, the Control-Shift-X option, where we put our Wi-Fi password and user, or network name. I think you can also change this in here too, but they're having you change it afterwards. So you can change those to something other than Pi and Raspberry. That's the default for every one of these things. So why you're wanting to do this is that once you put it on your network, anyone who can get on that network could connect to your printer and cause it to do stuff. You know, cause it to do things that you didn't want it to do. Put it into modes where it has a failure mode or whatever. So you probably want to change the password so that they can't do that. They can't get on this little server that you've connected to your network. Let's see. If you change the host name, then this octopi.local won't work. So I never use it anyway because I don't have the Bonjour service running. So I always have to type the IP address anyway. So these don't really affect me. You don't need to expand the file system. You don't need to manually enable the the camera that you can add to it. If you have one, it will already be recognized and used. And then what you do at that point is, and so all of this you don't actually have to do. It just lets you change that username and password so that other people can't log into it as easily. So what you do then is you go in and you type in that IP address that you found, and it will bring you to a web page that is the Octoprint web page. Here's Thomas with a guide that you could also watch. I don't know if it's an install guide or just the setup guide. Here's the old version of how you set up the Wi-Fi. This might help if you're trying to set up one where you have to have a username. It probably doesn't though. Here's the image itself. So if you don't want to use this thing, this Pi imager, there's no reason to not use it. But if you don't want to use it for some reason, then you can download Octopi and install it yourself. Let's see if it gives you doesn't give you a preview of the Octoprint screen. The other thing, let's go look at plugins. The other thing that it does is now you have access to a lot of plugins that can enhance the... Oh, it's been frozen for a while. Yeah, it doesn't matter, but it looks funny. So let's see if we can unfreeze it. It's probably because I'm trying to do everything on the phone. see if it came back. All right. It'll probably freeze again at some point. Hopefully I get actual internet back before soon. We'll see how that goes. So these plugins, what they do is they add features. So the ones I like are, some of them are things like the time lapse. So Octolapse is a popular one. Let's see, it's probably, I don't know how they have these organized. It looks like they're kind of just random. or maybe by release date. Looks like, well, no, they're not even that. I don't know how they've got them organized here. Oh, most recently added. So Octolapse is one that a lot of people like. I have used it before. This one helps you make time lapse of your prints so that they grow instantly when you watch the video. That's one. Arc Welder. I don't know how that came up with Octolapse, but this is one that I do like, because what it does is your printer can use the arc commands, but the slicers don't use them. So I'm talking about in G code. So in G code, when your slicer like Cura tries to create the commands to print out one shape, it does that as a whole bunch of tiny little line segments. So if it's an arc, a curve, then it's really just a bunch of tiny line segments, and that's a lot of commands. But in G code, there are commands that are make an arc, make part of a circle. And this arc welder goes in and it analyzes your G code, and anytime it finds an arc, a series of line segments that would make an arc, it takes all of those out and replaces them with an arc command. So it's a lot smoother, actually. It compacts your G code file size, and instead of sending a whole bunch of line commands, it sends one arc command to replace the thousands of little tiny line segments that would create the arc. So I do like that one. It runs automatically, and it doesn't take long. It sounds like it's this long process, but it takes a minute at the most for a really complicated file to go in and replace all the things that could be arcs with arc commands. So I like that one, Octolapse. Dry run. So if you want to do some like turn your printer into a plotter type thing, so it'll let you print without heating or extruding. Or if you just want to see where a print is going to land on the bed, you can hit that, and it'll give you kind of a trace of where it's going to print. Maybe you're trying to avoid a spot of your bed that doesn't print well or whatever. I don't know this one, OctoSlack, but these plugins, they're super easy to install. Basically, you just click on the thing, what you have Octoprint running, and it will install the different plugins. And there are a lot of them. There are some, I don't see it here. I saw it earlier on the home page for this. The Spaghetti Detective. This thing, I don't think it's free. It might have some amount of free part to it. Yeah, you have some kind of no. Let's see, no credit card required. So that means that there is a way to pay for it eventually, but you get some level of free. What this does is it takes a webcam and it watches your print, and what it's looking for, it uses artificial intelligence to look for strings, the spaghetti. So your print has failed. So realize we're off the top. So it realizes that your print has failed. It's come loose from the build plate or whatever. And there's this, a massive amount of strings everywhere, or spaghetti everywhere. And it will inform you that, hey, your print's probably failed. And so if you have a really long print that you're not going to sit there and watch the whole time, this thing will basically sit there and watch it for you. Like I said, it's not free. You get some amount of free time. Let's see if it says. Well, their webpage is not. Well, it's probably my really slow internet right now. It's not helping with that. But there are all kinds of plugins like that, and you can find all sorts. Well, in fact, that video that we were looking at said the best plugins, according to Thomas anyway. So, best plugins. So you could watch that to get some idea. I like Arc Welder, Octolapse. I've used the Spaghetti Detective thing, but I don't really print that long without seeing my prints anyway, so it's not really saving me that much to do it, and it wasn't free, so I don't use it that much, but it is a thing you can use. So I don't think we're going to be able to actually log into my yeah, it never connected to the phone's service, which would probably make my stream even worse anyway. So we'll come back next time with actually getting in. Well, hopefully next time, whenever the internet is back normal, we'll come back and actually use Octoprint. Let's put this thing on, and that'll probably, yeah, we'll run out of time doing that anyway. All right, so this is relatively easy to install. No big secrets to it. Let's lower this. And raise our camera so we can actually see it and get it, because we're going to be back there. We're going to be back here. All right, so we need to take this stuff off, which for some reason I gotta find. There we go. Well, that one's actually pretty tight. This is the hardest one to get to back here. I'm going to have to cut the filament out of it because the printer's not on, so I can't get it out of the nozzle without heating it all up. So we'll have to figure that out. We'll just cut it out of there and it'll be fine. I'm not really sure why this is so tight. I guess because that spring is pushing on it. So these screws screw directly into the top of your stepper motor underneath here. So once you take all the screws out, there's nothing holding the stepper motor on. So be sure that you have it supported some way, or you just don't want it to damage something. Right underneath it right now is the bed. So I wouldn't want to put some kind of hole in the bed or whatever. If I can get this spring out of here, well, can't really get it out though. All right, we'll do these others. Oh, they're a different size. Let's go ahead and unscrew this too. And the filament might be part of our problem. This one's underneath that screw, so we got to take that out. This screw, you can use it to apply more pressure between the pulley and your gold drive wheel there, but right now it's in the way. Oh, and I'm not going to be able to. There it goes. Okay. Save all those pieces, I guess. All right. Let's get the rest of this out. They're definitely in there pretty tight to start with. So this is where the stepper motor is going to come loose if we just let it fall. All right. We're going to also take this. Well, you can't see it. We're also going to take this guy off. Oh, wow. Maybe we're not. This is tougher than I thought. So normally these have a set screw, but this one is a press fit. and I did not come prepared to remove a press fit. Let me see if we can get that off of there. Otherwise, I might just get a different stepper motor. So I don't know. Normally, this is the first one I've seen that was just a press fit on there. And normally to remove a press fit like this, you're going to have to heat it up to get it to pop off of there. And I don't really have a easy way to do that right here at the computer. But we will see just how much of a press fit it is. It's pretty tight. Yeah. Let me see if I can just grab another stepper motor. All right, so we're going to cheat. This is how they normally are on there. There's set screws. So we will use this stepper motor. Oh, yeah. Make sure it's not one I've taken apart. Let's see, I'm kind of off in the screen. Actually, this is not how they're normally on there. This is upside down from what they're normally. This is turned the other way, I think, but I don't know. So if you might check this first if you want to change out one of these. If you have one that's a press fit like this, it is going to be a little bit harder to get off of there. And you can tell, you know, I just never looked because I didn't know they even had any that were press fits. But if there's no set screw on there, then you're gonna probably have to heat this and then use something to pry it off of there, unless you happen to have a tiny little pulley remover, which I don't have a tiny little pulley remover for that size. But I have another stepper motor, so assuming that this one's not broken somehow, which it doesn't appear to be, we'll just use it. Let me make sure it's, yeah, I think it's fine. Seems fine. All right. And it should have the same connector, so we should be able to just plug it back in. There we go. All right. So this guy is going to mount in here. And let's get all our pieces kind of assembled. Well, let's put our plate on first. And I don't know if you noticed or not, but this, whoops. This screw is a countersink screw, so you do have to make sure you match it up because it has to sit flush so that this lever can ride across the top of it. So you do have to get that one in the exact right spot. Oh, they're all different sizes too, so it's a little bit annoying. Okay, that'll hold us in place. Now, you've also got one that's really long. That one's going to be the pivot for the handle. The handle also has a sleeve, usually. Oh, here it goes. This little sleeve. You drop that in, put that guy in, and then it's going to go in the back corner. Oh, that's a different size. All right, I'll be right back. So now we need to get our drive screw. Now this one we need to make sure that we line up the little gear parts. And it only has one set screw, and this particular stepper motor does have a flat edge on it, on this shaft, which of course is turned the very wrong way for me to line it up. So line that set screw on the flat edge. Oh, does it have to? I think it might have to go on first because it doesn't clear this. So there is a order of operations that we didn't follow apparently. Let's see if we can just loosen it up to where there's enough slack in there. No. All right. Fine. I have to take the stepper out and put the gear on first. Okay. So let's put the gear on here and line up the set screw with the flat side. And we won't know exactly the right height yet, so let's just kind of get it on there and more or less right, and then we'll line up the right height later. Okay. Now it'll go in there. Don't tighten all of these down until you've got them all in. The other two are just plain, except they're the smaller size. I don't really like this everything is its own size idea. But that's what they've got. Okay, so those are all in. Let's go ahead and tighten the base plate down. And then we need to set the height on that gear. Okay. Let's find our tiny little guy. All right, so that looks more or less right. Now we need a spring in here. They gave us one of these really heavy duty yellow die springs. It has a screw that, yeah, we're going to put in from this side. I probably should have done that already, but we'll do it now. We'll just go this way in. This is kind of what holds the spring in place on the handle in here. So you just, it doesn't do anything other than it locates the spring. So we just screw it in. It doesn't have a hole, a through hole, so you just kind of do something like that. Put the spring, well, this little guy sits in the spring. Now you got to get that spring in there. It is pretty stiff. Okay, and then this larger screw will go here and screw into that little gold ferrule thing that we put inside the spring. And that'll, I mean, the spring is pretty stiff as it is, but you can actually tighten this screw to create more pressure if you need to. Like you can shorten the spring. It's really stiff already though. I don't think you ever really need to do that. but you get a new one of these. The old one threads will not, they're not compatible, so you got to put the new one in there. Now I see where I cut off the filament really close to the end here, so that might create a little problem for us. But there's enough that we can grab. I want to heat up the hot end so that we can pull the filament out. So changing this shouldn't. It could change your E-steps, so it would be a good idea. It may or may not affect them, but it could change your E-steps a little bit, depending on if this diameter is any different from the diameter that's going to be driving, which it looks like I have a larger diameter here than I did here. So now turning this is not going to have the same effect on putting filament through. So it probably will change my E-steps. So I will need to go in and check those, modify them to a new value. We can do that real quick once I get this filament out of here. Well, what time is it? Yeah, we might actually have time to do it. Let's see what while it's heating up, let's see what my current E-steps are. So, all right, so I'm in the menu over here. Let's see, configuration. I think it's in this menu. Remember, I'm using that TH3D menu. Advanced settings, steps per millimeter, E-steps. I'm currently at 97.7. So I'm over here in this E-step calculator, th3dstudio.com E-step calculator up here. My current are 97.7. I'm going to extrude 100 millimeters once I get some filament in there. Let's chop this off at an angle. All right. Cut it off flush there. Looks like we're able to pull this out now. All right, so now I'm going to go over here to motion, move axis in extruder, 10 millimeter. I'm going to do 100 millimeters. And we'll see what we get. Filament's kind of off to the side. Oh, you're covered up. There we go. All we're doing is extruding filament out of here. And I use the control panel to tell it to extrude 100 millimeters. Get my calipers and see how close to 100 millimeters we get. It's going very slow, but typically whenever you are doing this E-step calibration, you don't want to send it out super fast because you at least stand a chance of skipping a step or something like that. If you go slow, typically you're extruding filament pretty slowly anyway. All right, it's done. So it's fine that it's going kind of slow. All right. So I actually got zero out my caliper. Zero. And let's measure this thing. I got 70.5 millimeters. So over here in my calculator, the actual length was 70.5 millimeters. My new E-steps should be 139. So let's go over here to configuration, advanced settings, steps per millimeter, E-steps, change it to 139. We would, if you didn't do this after changing this top on here, you would certainly be off under extruding. So 139. Save settings, or well, what are they called? Store settings. That's the confirmation beep. Motion, move axis, extruder, 10 millimeters at a time. 100. And let's see if we get any better this time. You usually want to do it a couple of times just to, you know, make sure you don't overshoot or undershoot or whatever. Or maybe you clicked the wrong button on the LCD screen and you only told it to do 90 millimeters. So, who knows? If you get to, you're trying to do the E-step calibration and it won't extrude, it's probably because you haven't heated up the nozzle. Most printers have a built-in safety thing that they won't extrude filament if the nozzle is not at printing temperature, like 170 or something like that. All right, let's see what we got this time. We definitely got more. So let's see. A little bit hard to measure when it's curved. Usually I draw it or mark it on a piece of paper and measure that. But I guess I'm just being... Actually, I've got a little scale right down here. Let's just hold it against that and see. If anything, it's a tiny bit short, but I think that's just because it's curved. I'm going to say that that's good. All right, so we would have definitely had under extrusion problems if we had left it alone, because originally we had this much larger diameter feeder gear, and then we replaced it with a quite a bit smaller diameter one. So it would make sense that it's not going to extrude the same amount per step if we don't change that. So I'm going to put that back in. Put our little clip, if I can pick it up. It's very, there, put a little clip in there. And should be good. We'll print some more things and see, you know, maybe we can print the other half of this guy and see if it'll work pretty well without skipping. All right. Well, I will work on my internet to try and get so we can actually look at Octoprint. We installed it, it was running, we just can't actually access it. I'll be able to access it once I shut down this and connect to my local network, because it's not the internet that's important, it's the local network so that my computer can talk to the printer. But I can't do that while I've got it connected to the phone also at the same time. So we will be back on Monday, hopefully with internet, and look at Octoprint. I actually have scheduled, in the event that we don't have internet, then I have in topology. I think I'll actually move the SolidWorks and Fusion 360 up. These are all kind of the same thing. These are topology optimization routines. So they're software-based ways to go in and modify geometry to make it more rigid with lighter weight, you know, or something like that, to optimize the topology or the geometry so that you have the least amount of material supporting the most amount of stress or weight or whatever you've optimized for. And SolidWorks will do that. So will Fusion 360, although you usually, you might have to pay for that one. It's currently, a lot of times I get it free and sometimes I don't. So we'll see how that works. In topology is not a free, it's a software suite. So I don't know if we'll do it first. I think we'll do the ones that we're more familiar with first. And hopefully we'll get to do some Octoprint. All right, I will see y'all on Monday.